Thank you for joining us again on Djji Tutorials. Today we are diving into multiplication and division of functions and composite functions. Multiplying and dividing functions involves performing those arithmetic operations on the function's corresponding values at each input point. When multiplying functions, the resulting function's value at any given input x is the product of the individual function values at that input. If you have functions f of x and g of x, their product f times g of x is defined as f of x times g of x. The domain of the resulting product function is the intersection of the domains of the original functions. Division. When dividing functions, the resulting function's value at any given input x is the quotient of the function values at that input. If you have functions f of x and g of x, their quotient, f divided by g at x is defined as f of x divided by g of x, provided that g of x does not equal 0. The domain of the resulting quotient function excludes any input values that would make the denominator g of x 0. Let's take an example. Let f of x be 2x plus 1 and g of x be x minus 3. Now, for multiplication, we have f times g of x, which equals 2x plus 1 times x minus 3. Simplifying this, we get 2x squared minus 5x minus 3. For division, we have f divided by g of x, which equals 2x plus 1 over x minus 3. It's important to note that x cannot equal 3 in this case. Chapter 3. Composite Functions. A composite function is a new function formed by combining two or more existing functions, where the output of one function becomes the input of another. The notation for a composite function where function f is composed with function g is typically fg or fg(x). It's read as f composed with g or f of g of x. Here's a breakdown of the concept. First, combining functions. Imagine you have two functions, f of x and g of x. The composite function, fg, is created by substituting the entire function g of x into the input of function f of x. This means the output of g of x becomes the input for f of x. Notation and meaning fg. This notation indicates that function g is applied first, and then the output of g is used as the input for function f. Gex. This is the explicit form of the composite function where g of x is directly substituted into f of x. Example, let f of x be 2x plus 3, and g of x be x squared. Then the composite function f of g of x would be f of x squared, which equals 2 times x squared plus 3, resulting in 2x squared plus 3. In essence, creating a composite function is about chaining functions together, where the output of one serves as the input for the next. Please share with your fellow students. See you next time.